Hello guys, in this video we are going to discuss the solution of the problem count all possible path. So let us look at the problem statement. So the problem statement says that you are presented with an undirected connected graph consisting of n vertices and connections between them represented by an adjacency matrix. Your objective is to determine whether it is possible to start traversing from a node X and return to it after traversing all the vertices at least once, using each edge exactly once. So we need to traverse all the vertices, and after traversing all the vertices we need to return to the source vertex, which is X in this particular case, and also an edge which we have already traversed, that edge we cannot traverse it back. So given such a graph, if it is possible for me to traverse all the vertex and come back to the source, then for such cases I am supposed to return 1, otherwise I will return 0. So let us try to understand the problem with the help of an example. So let's take the first example which is there in our question. So let me just plot the graph for it. So this is the graph which we have, and if you see in this particular graph, what we can see from here is that if we take this path which is from 1, I can go to 3, and then from 3 I can go to 4, and then from 4 I can go to 5, and from 5 I can go to 1, and then from 1 I can go to 4, and from 4 I can go to 2, and from 2 finally I can come back to 1. And if you see here, I have traversed all the vertices. So what vertex 1 is traversed, vertex 2 is traversed, vertex 3 is traversed, 4 is traversed, and fifth vertex is traversed. So since I was able to traverse all the vertices and I was able to come back to my starting vertex, which is 1, thereby for this particular graph there exists a path, there exists such a path, and that is why for this particular case I am going to return 1. Okay, let's take one more example to understand the problem statement bit better. So let's see this graph. So this is the graph which we have. So if you see here, it is not possible for me to find a path via which I'll be able to start from a source and reach back. And the reason for that is, if you see this particular node, node 4, so if you see this node, from here I can just reach this node. So let us say if this is my source node, so from here I will be able to use this edge only once, and once I have used this edge, there isn't any other edge via which I'll be able to come back, and that is why we can conclude that we will not be able to find a path via which we will be able to traverse all the vertices and come back to source. And here please note that here we have to use the edge exactly once. Once we have used the edge, we are not supposed to use the same edge again. Okay, in this particular case we are going to return 0. All right, so that's about the problem statement, folks. Now let us see how we will be able to solve this problem. This is the graph which we have. Okay, so if this is the graph, so what we are going to do is we are going to compute the degrees of each of the nodes. Okay, and degrees simply means that from one node how many edges do I have. So if you see vertex 1, so from here I have 1, 2, 3 and 4. So the degree of this is 4, and the degree of this particular node is, or this vertex is 2, since 2 edges are here. Here also it is 2, and here it is 4, right? 2 to 4, and here if you see it is 2. All right, let's take the another graph. Okay, so if you see the degree of these edges, now these vertex, then the degree over here is 2, here it is 3, and here it is 2, and here it is 1. So what we can see here is, for the case where all where the degree of all the vertex were even, we are able to form a graph, and here we will be able to return 1. Okay, for the cases where not all the vertices have even degree, for such cases we are going to return 0, right? So if you see this, and I'll explain in a bit why is that the case, but if you see from a general um, observation point of view, so if you see here all the degrees are even, that is why we are able to form such a path, whereas in this particular case not all the degrees are even, because of which we are able to return 0. So in order to understand that why this is the case, let us analyze the cases where the graph, the degrees of each of the vertex of the graph is even. Okay, so if the degree of each of the graph is even, then so let's see this. So let us say this is a node. Okay, and let's say this node is some node which is a x, and here we know is the number of the edges here is, or the degree of this node is even. Okay, so what it simply means is it will be the 2, 4, 6 and so on, right? So what it simply means is if I use one of the edges, so let's say if I use this edge to come here, right? Then I can use the corresponding edge or the other edge to go out from this node, okay, to go out from this vertex. Whereas if you see, if you take an vertex whose degree is odd, okay, so let us take this is another vertex whose degree is odd. So let's say that vertex is only this, right? So since the degree is odd, so here what the possibility which we have is 1, 3, 5 and so on. So if it is 1, then there is just one edge via which we will be able to come to this vertex, but once we have come to this vertex, there is no way by which I'll be able to go out of this vertex, isn't it? Because of which, if you see this, if you consider this to be your source, right? If we consider this vertex to be our source, then we can go out of this vertex, but we will never be able to reach this vertex. If you consider this vertex, so if this is not a source, or so it will be somewhere. So let's say we will start from 1 to 2, we went to second vertex, we went to third vertex and so on, and we went, and then we reach this vertex, and let's say, call this vertex as y. So then we reach vertex y. Now we can reach this vertex, but we will never be able to go out of this vertex, right? So that is why we can say that if there exists at least one vertex whose degree is odd, then with that graph, or in such graph, we will not be able to form the path which is given in the question, and that is why we are going to return 0 to it. Okay, so I hope the case where the degree of a particular node is odd and that degree is 1 is clear, and that is why we will not be able to, or why we are returning 0 in that particular case where the degree of a particular vertex is 1. But I'm sure you will have confusion for why, if it is 3 or 5, then also we are returning 0 in such cases. So let us take a vertex whose degree is 3. So if the vertex degree is 3, then there are 3 edges from it. Okay, so if you see here, it is possible to come to this vertex from this edge, and it is possible for me to go out of this vertex with this edge. But how about this edge? Okay, so now the remaining edge, or this edge, I'll be able to come back again. Okay, but once I come back, there is no other edge by which I'll be able to go out. All right, so that is why for all the vertex whose degree is odd, we will be able to come to that edge, but we will not be able to move out of that edge. Sorry, we will be able to come to that vertex, but we will not be able to move out of that vertex. Since that is the case, because of which we are returning 0. So that's about the explanation, folks. And once we understand this concept, the code becomes really, really easy. So let us look at the code. And the code is something like this. For a given vertex I, I'm finding out the degree of that vertex. Okay. So the degree of the vertex is I'm keeping it in the variable count. If the degree of vertex is odd, okay, so this is an odd check. If the degree of the vertex is odd, then we are going to return 0. If the degree of all the vertices are even, then in such cases we are returning 1. So that's the code, folks. Now let us submit our solution. So our solution got accepted. That's from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I will try to address them. Thank you.